With SAAO, we've recently discovered this spectacular binary central star of a planetary nebula. It's a very peculiar case because it's only the second central star known to have a Wolf-Rayet component in the binary. Only one other has been found so far. While we know of around 40 close binary central stars of PN, none of them have a Wolf-Rayet component except for these two objects. The object we've been studying in particular is NGC 5189, and with SAAO, with the Q-based operations, we took 14 spectra over 3 months, and this allowed us to build up enough sensitivity to different orbital periods. And we looked at the radial velocity motion in this binary and found a period of about 4 days, proving that there's a binary companion there. Since the 1980s, people have thought that there was a binary system here to explain the very unusual shapes that we see in the nebula. A very strong S-shape in the nebula that theory tells us there should have been an accretion disk around this companion, around the companion star, producing this processing outflow in the nebula. But no one's found it before. All you see in the optical when you monitor the brightness of the central star is very small pulsations. There's no strong orbital signature there. But the observations we've done with SAAO tell us there is a massive white dwarf companion, which explains why there is no optical change in the light curve. And the long orbital period also suggests that there are other companions to Wolf-Rayet central stars out there at slightly longer orbital periods than we expect in these systems. So we see this object as opening up a whole new parameter space in this whole search for explaining how planetary nebulae are shaped and how they form. Well, SAAO being a large telescope, you can access this particular blue part of the spectrum very nicely at decent resolution to show the small radial velocity changes over time, and building up the number of observations we need over several weeks is perfect. You can't do this easily over a 1 or 2 week traditional observing run.
With my colleague Brent Miszalski, we look for peculiar objects with emission lines, in particular for new symbiotic stars in our galaxy and Magellanic Clouds. And symbiotic stars are interesting for us because they are important to understand stellar evolution. And that's because both of the components of these binaries are very evolved stars. One is very large, very cold, and often has very strong wind. The other is very compact, very hot, even more evolved than the giant star. And as they interact, we see many interesting phenomena like outbursts. They also ionize the surrounding material, so we have spectacular emission line spectrum. Sometimes we can resolve the nebula. And so for that reason, it's very interesting. And with SAAO, we can look for the fainter one. We also can get high quality spectra, and thus far we found about 30 of them, and we hope to find more. And second thing which we do once we have these stars identified, we use the high resolution spectra to measure their masses. And this we do using Doppler effect. So we look how the lines are displaced, and then we can, once we have the velocities, we can get masses. And that's again very interesting because we hope that at least a few of them will have very massive compact component, and some of them they even can evolve to supernova type 1a, which are very interesting for astronomers.